Hello friends, good afternoon and welcome to the EduSat Network. Our topic of discussion today shall be climate and controlling factors with respect to temperature and pressure, and for this very discussion and lecture we have with us in our studio Dr. Anju Singh, Assistant Professor, Department of Geography, Aditi Mahavidyalaya, University of Delhi. Dr. Singh has been teaching for more than a decade. Friends, with this introduction I'd like to welcome her to our studio and also request her to begin our today's lecture. Thank you for coming, ma'am.
Thank you, Urvashi ji, and a very good afternoon to all of my viewers. Today's discussion already mentioned by ma'am, climate and controlling factors. This topic is very relevant and basic and important part of our climate study, because climate influences our everyday life, and climate as an independent factor, apex of independent other factors control our whole environment and human mankind. There are so many examples which proves that my statement, and for example, either the last week storm of in Bihar and flood of Kashmir Valley, and tragedy of Uttarakhand in 2013, and recent issue related to farmers which raised by unexpected rain, all are the indicators or are closely related to climate. So I select a topic for discussion today. Climate. This topic is divided into two parts, and I discuss half temperature and pressure, an important component today, and other factors in my tomorrow presentation. As we know, climate is a sum total of meteorological element that characterize the average and extreme condition of the atmosphere over a long period of time at any place or region of the Earth's surface. The atmosphere is atmosphere never is statics, and it is changed especially and temporally, place to place and time to time. And all there are several variables in climate, and which controls their magnitude of changes. Different climate are found in different parts of the world, which are the result of many extensive or interactive processes involving the land, its feature, ocean and atmosphere. So our climate consists mainly by our atmosphere, continent, ice masses, and our biological masses also. Through general circulation of atmosphere and ocean, wind and current regulate the heat and moisture around the whole earth, and all these shape the character of climate of any place. So element of climate are already known, and these are the basic temperature, barometric pressure, cloud type, height above the sea level, which are also known as altitude, oceanic current, precipitation, sunshine, and wind velocities. All these factors influence climate from one place to another, from one season to other, and all these are known as a control of climate. But I select for this discussion for four basic factors of climate, and these are known as a basic controller of climate. These are air temperature. All the various factors, these are more important, as these are air temperature, air pressure, wind, and atmospheric pressure. Air pressure of any place is the result of sun insolation which come from sun, and temperature is closely related to air pressure. As temperature increase, pressure also decrease. Wind is another factor which is closely related to air pressure. As change in pressure of any place, winds can ready to flow from one place to another. Through wind, imbalances of Earth's surface maintained. As for example, in tropical region there is a net gain of energy, but at the same time in polar region net loss of energy. So winds migrate through movements. Winds equalize all these inequalities. Atmospheric moisture is another important factor, and atmospheric moisture we are known as a humidity of atmosphere and water vapor. Water has a tremendous capacity to change climatic condition, as it is a change in different state of our, sometimes it is found in a liquid state, sometimes found in a gaseous, and some found in a solid state. So, all this reason moisture or water play a very important role in our climatic variability and climatic condition of the any place or earth surface. Because water has a main controller of or energy balance, and it is affect the solar insolation through clouds, and also atmospheric moisture play through the evaporation and condensation transfer energy from earth surface to atmosphere. So, all these factors are very basic and all related to each other also and affect. Now, first I want to take to discuss temperature in detail. Temperature refers it to its intensity, and that is the degree of hotness. How much is the any place is hot and cold is a measurement of temperature. The temperature of any particular place depends primarily on the amount of insolation received there. Amount of received of amount of insolation received at different place at different in amount, and all there are other factors which affect the amount of insolation, and they are known as the control of insolation. For example, length of the day, angle of the sun rays, transparency of atmosphere determine how much amount of insolation received in at any place. And no doubt length of the day and latitude is one of the important. Latitude, this figure show the how latitude affect the variation amount of temperature at different place. Sun is sun move from Tropic of Cancer to Tropic of Capricorn, Tropic of Cancer to Tropic of Capricorn, and by this the angle of sun rays vary at different place at different time. When sun is overhead on Tropic of Cancer and between the equator, this tropical area is known this area is known as a tropical condition, and here the amount of insolation received much in other comparison to other part of the area. So, it's when rays vertical overhead at equator getting more amount of insolation, then an inclination of rays go as vary as go from equator to poles, and according to this also change in amount of insolation. Many other factors are also controlling the temperature, these are the latitude, altitude. Latitude I already mentioned. Altitude is another factor which change temperature at different place. Temperature decrease with increasing altitude from the earth's surface, and the average rate of decrease of temperature upward in the atmosphere is 6.5 degrees Celsius per 1000 meters, and this is known as normal lapse rate also. Oceanic current is also other factor. Oceanic current influence the temperature of adjacent land areas considerably, and oceanic current move from one place to another in order to equalize the temperature as like wind, and when there are large amount of oceanic water usually from place to warm temperature to one of the colder temperature, and vice versa. There are two types of oceanic currents, warm and cold. Warm current raise the temperature of that place, and while the cold lower them. Nature of land surface is also affect of temperature. Different climate of different kind of surface reflect different amount of incoming solar radiation which falling thereon. For example, bright and smooth surface absorb less amount of heat, and then the roughed one like a sandy area or dark black soil area absorb much of amount of energy. Area covered with snow reflect much of the incoming solar radiation, and temperature of that place is remain low. So, lighter surface reflect the much of energy, solar energy, and darker surface receive much of amount of insolation. Texture, color, and also affect the insolation. Cloudiness, the atmospheric depletion of insolation is relatively less in those regions that have clear and cloudless sky. Areas having more clouds do not expressing high temperature because cloud reflect to space much of incoming solar radiation. Distribution of sea and land also react differently towards incoming solar radiation. Land surface hit more quickly and at a greater extent than the water surface when subject to an equal amount of insolation, and it's also cool more rapidly. Greater extreme of temperature are fall over the land than over the sea. And there is example for this reason Mumbai is more temperature is low than Delhi because it is located near the sea. Beside other factors, atmospheric condition process are also affect or minimize the insolation by different processes. They are through these processes lost much of energy in atmosphere, and these are these are scattering, absorption, diffusion, reflection. Scattering, when sunlight strikes very small objects such as air molecule, dust particle, the light itself is deflected in all directions, up, down, sideways, in which blue light is much more easily scattered than red light. So, therefore, our sky looks blue. At sunset and sunrise, at the time of sunset and sunrise, sunlight must pass through more atmosphere. So, the reaching of eyes. So, the blue light is almost entirely scattered. The sun itself appears ruddy and yellowish. On the other hand, aerosol and water droplets scatter visible solar radiation equal at all wavelengths, so that mist appears white and the sky looks hazy when the air pollution is severe. Absorption, due to absorption, much of the energy absorbed by atmosphere, and there has no role to heating Earth's surface. So, due to the process of absorption also reflect the temperature of Earth's surface. Solar radiation is also in the atmosphere through different gases and water vapor and various aerosols. Ozone and oxygen is the main important gas which absorb much of our energy. Atmospheric gases selectively absorb and emit radiation. When sunlight reaches at the top of the atmosphere, shorter wavelength radiation is absorbed first at the higher atmosphere. UV radiation, whose ultraviolet radiation, whose wavelengths are shorter, is absorbed almost 100% by oxygen, and ozone at the stratosphere. Infrared radiation is absorbed by water. So, there are different elements have different quality, and they also a rate of different absorption according to components. Diffusion, the scattering of incoming solar radiation waves by dust particle and molecules of water vapor. When the diameter of these particles is larger than the wavelength of coming solar radiation, it is called diffusion, which send some portion remains in the lower atmosphere. Reflection, reflection occur when a part of incidence radiation striking a body is reflected from its surface, and reflectance varies considerably in amount of natural surface. Cloud are the most important reflectors, and it's act as a reflectors in the atmosphere. But at the land surface, our ice cap area or snow cover area reflect much of the energy of solar received by solar radiation. So that's why and this is the reason the polar or ice cap region or high mountain peaks are have low temperature in that area, and the reflecting amount of insolation is called by albedo. Albedo almost 30%, 35% of the insolation reflected by land surface. This figure show the whole heat budget, and in the right this portion shows the total outgoing radiation, which radiation re-radiate from the earth's surface towards atmosphere, and this also known as a terrestrial radiation. This in this portion show all the radiation coming from space to atmosphere, and how much of radiation absorbed by different elements, gas, aerosols and water vapor, and how much, like about only 50% of energy received by Earth's surface. Because the spherical shape of the Earth, heat balance is not maintained by each latitude. At high latitude, outgoing radiation exceed incoming solar radiation, and at the low latitude, on the other hand, incoming solar radiation exceed outgoing terrestrial radiation. Only at the middle latitude, incoming solar radiation and outgoing solar radiation are the balance. If these were true and nothing compensated it, the tropical region is more continually get hotter, and polar regions would continually get colder. This figure show the mean annual distribution of energy balance according to latitude, and in this figure we can see the blue show the blue line of total receive of temperature at different latitude, and red line shows the total amount of net loss of insolation at different latitude. We can see the two polar region of deficit, region of energy deficit are matched with the single region of energy surplus, and also we can see at the latitude of 30 degree total heating and cooling of the earth's surface is equal. So this is the mid latitude where the temperature of net gain or loss are equal. So to compensate this deficit and surplus of energy, winds in the atmosphere and current in the oceans circulate warm air and water towards the pole, and cold air and water towards the equator. Since wind circulation and oceanic circulation transport excess of energy from the lower latitude to higher latitude, and by this the mean annual temperature of the whole earth maintained. The amount of incoming energy average over the entire energy of the earth is equally maintained. Distribution of temperature is not so much easy, because there are several other factors which affect at the ground level. For example, we already mentioned distribution of land and ocean, distribution and movement of oceanic currents. All are factors shape the total amount of insolation at and they are changing their magnitude at different level in Earth's surface. So distribution of temperature, there are so many characteristics we can see at different, and this is the map of distribution of January temperature distribution, and this is distribution of temperature, and this is the horizontal distribution of temperature in July. So distribution temperature is always high in tropics, which show in map, and very low temperature experienced in polar area. The isotherms of temperature run parallel to the latitudes because amount of insolation is received and some amount of experience by almost all points located at the particular latitude. Isotherms exhibit some notable north to south bends primarily due to land and ocean contrast and the influence of ocean current also. There is a uniform temperature distribution in southern hemisphere as compared to northern hemisphere. Highlands are always colder than surrounding lowland. The annual range of varies small our ocean and then the land because ocean has water has a tendency to takes time to getting hot and also takes time to cool. As comparison to land, lands quickly hot and quickly cool. So this is the reason in the daytime the temperature of the land area is every place has higher at the same latitude of the water areas. Normally temperature decrease poleward from the tropic and subtropics. In the northern hemisphere, the isotherms generally are closer together than they are in July, and in the southern hemisphere, isotherms in July are closer together they are in January. In the January, there is a summer in northern hemisphere, summer in southern hemisphere, and winter in northern hemisphere, and we can see the sea area or water area has a higher temperature than the land area. Distribution of temperature in January found higher temperature at northwest Argentina, east central Africa, Borneo, central Australia in southern hemisphere, and northern hemisphere, northeastern Asia experienced lowest temperature. Isotherm bends towards equator when they cross the landmass and towards pole when they cross the ocean in the northern hemisphere. In the southern hemisphere, isotherms bend towards poles when they cross the landmass and towards equator when they cross the ocean. In this map, isotherm shows the temperature of July, and that time northern hemisphere experience summer and southern hemisphere experience winter season. In southern hemisphere, so at that time, as land heat up early or quickly, and then the water area, so there is a high temperature region located in land in comparison to the same located area on ocean. Then it's distribution of temperature in July. Some features we can show. These are the area of high temperature at Afghanistan, Gobi desert region of India, Sahara, Arabian experience high temperature region, and also isotherm bend equatorward while crossing ocean and polewards while crossing landmass in the northern hemisphere. Importance of temperature. Important of time. There is very important component of climate, since it will determine pressure. Temperature influences the actual amount of water vapor present in the air and thus decides the moisture carrying capacity of the air. It is also decide the rate of evaporation and condensation. Without much temperature, evaporation process is not occur. So these are the factor evaporation and condensation by which water circulates in atmosphere through hydrological cycle, or water transfer from earth to atmosphere. As relative humidity is directly related to the temperature of the air, it affects the nature and types of cloud formation and precipitation. So, temperature is a very important factor. So, another factor is atmospheric pressure. Pressure of the air. Pressure is the weight of air of any given place, and air has its own weight due to which it exerts pressure on Earth's surface. Pressure exerted by atmosphere is known as atmospheric pressure. Air is compressible fluid, the full of gravity, and cause it to be most dense near the ground, cause the pressure to decrease rapidly with the altitude. In starting, pressure decrease quickly, and in the height, as height increase, the rate of decrease of pressure also slow down. Temperature is closely related to temperature. Where at any place the high temperature region we can experience lower pressure area, and in the low temperature region you experience a higher pressure area. These are the factors which pressure primarily depends on. These are three basic: altitude, temperature, and Earth's rotation. Air pressure decreases rapidly at the first, then more slowly in the higher latitude. The height of air column is maximum at sea level, and the pressure of air is also maximum there. Air is a mixture of gases, so highly compressible, and so the density of lower layer is increased due to the weight of the overlying layer, and this increased pressure in the lower of atmosphere. Heavier gas remain confined to the lower air, so and other side lighter gas float higher level. So, the pressure in the lower layer is higher than the upper layer of atmosphere. When air is heated, it expands, and when it happens, the outward pressure, its molecules is spread over a large area, and this means the pressure of the air decrease. When air is cooled, it contracts, and when this happens, the outward pressure of its molecules is spread over smaller area. This means that the pressure of the area increase. The concentration of water vapor also influences the air pressure. Water vapor reduces the density of the air. Gravitational pull of the earth is also maximum as the lower air layer of the atmosphere, which increase the atmosphere there. Low temperature at the poles result in the contraction of the air, and hence the development of the high pressure area. High temperature along the equator result in the expansion of the air, and hence the development of low pressure area, and this is the reason of depression, low pressure depression, or is also known as a doldrum. There are total 7 pressure belts on Earth's surface. We can see in figure, all are alternately located, low, high and low. This is in center, the located equatorial low pressure area. Above the equator, about 25 to 35 at the about 25 to 35 degree subtropical high pressure area located in both the hemisphere, and another low pressure area located in about 60 degree of latitude. This is the subpolar low pressure area, and at the pole there are 2 other low pressure and high pressure regions. There are 2 types of factors which affect the pressure belts. They are thermal induced factors and dynamic induced factor. So, there are 4 type of pressure belt, 3 in each hemisphere and 1 in center located at equator. So, first at equator and poles, 2 pressure belts are thermal induced, and 2 center located belts of subpolar low and subtropical high are dynamically induced. and these are the factors. First, equatorial low pressure belt. The equatorial region experience low pressure. Why? Because here amount of insolation is maximum, and this will lead to development of low pressure here. Equatorial trough of low pressure is located between 5 degree north and south of the equator. Subtropical high pressure belt. The area of subtropical high pressure belt located between 25 to 35 degree of latitude and both the hemisphere, and there is two regions responsible for high pressure condition in this area. One is the warm air, the warm air of equator belt gradually cools down when it goes up in troposphere and turns towards the north and south in the northern and southern hemisphere respectively due to the rotation of the earth, and this is the dynamic force. The air completely turn on reaching the Tropic of Cancer and Tropic of Capricorn respectively in both the hemisphere. Tropic of Cancer located in northern hemisphere and Tropic of Capricorn located in southern hemisphere, and is starting descending there. Thus, descent of cold air cause high pressure condition in the belt extending from the tropics to 35 degree north and south of latitudes. And other second factor is also very important and shape a reason behind the tropical high pressure belt is large air masses in this area. Large air masses drift from the polar area to the subtropic area due to the earth rotation, and here is also a dynamic force and cause high pressure there. So, the descending air creates a calm condition with variable and favorable winds in this high pressure belt. They are therefore called belts of calm and harsh latitudes. All the desert of the world are located in this area because there is a lack of precipitation, lack of water, amount of water, and here temperature is high. So, that is why there is all the desert located in particular this area. This is the area of high pressure belt. Another third important belt of subpolar low pressure belt. This is also this belt is also dynamically induced because in the middle of the latitudes dynamic forces are more active. The area of subpolar low pressure belt located between latitudes 60 degree to 65 degree north and south of the hemisphere, and two factors are responsible for this low pressure belt. First, due to the axial rotation of the earth, the air is blown away from the poles and cause low pressure at the poles. Second is warm ocean currents from the tropical and subtropical area carry lot of heat to the subpolar area and create high temperature and low pressure condition there. In the southern hemisphere, there is an uninterrupted belt of low pressure between these latitudes where there is a vast expanse of ocean. It is different from northern hemisphere because they are equal in equal amount of land and ocean surface. Another important pressure belt is polar high pressure belt. This is also a thermal induced pressure belt caused by because at the pole there is ice cap region. Here reflection is very active and total amount of insolation received less and total loss is more at pole area. So, net and loss due to the more gain this area is suffer of deficient of energy and cause extremely low temperature. At the poles which remains below freezing point must develop area of high pressure. This is a figure show the pressure belts of wind pressure belt and wind system. We already discussed the several pressure belt in the located on Earth's surface. High pressure belt, low pressure, both are alternately located from equator. At equator low, and this is the high pressure belt of mid latitudes located at 30 degree, and another is 60 degree at low pressure, and here is the high pressure area. This figure show the general circulation model. General circulation model is represent the average air flow around the world or around the Earth's surface. Because due to the uneven distribution of temperature, some area getting more insolation and getting more heat, more energy than the polar area. So, for due to for balancing of these inequalities, general circulation develop. General circulation model by winds actualize the differences. They transport water or air from equatorial area of high temperature. It means warm air transport towards cold layer and cold layer transport towards tropical area. And in this process there are several circular cells are we can see here and develop. These cells are known as Hadley cell, Farrell cell and Poral cell. All the cells are discussed, I will discuss in the my next presentation, which will on tomorrow in section of wind, because it is a part of the winds. Here is the distribution of pressure in January, and as we know, pressure is controlled by controlled by air temperature and surface temperature. So, there is according to because at that time distribution of pressure in this map show the distribution of pressure in January. At that time January in northern hemisphere experience winter season and southern hemisphere experience, that time land area experience low of temperature in comparison to ocean area. So, high temperature area located at center of land masses like Central Asia, Siberia, and whole yellow color shows the high pressure region, and the maximum 1032 millibar of isobar located in Central Asia. At the same time, ocean experience low pressure, and there is we can see the two vast low pressure region of Atlantic Ocean and Pacific Ocean, and it is but at the same time in southern area land experience low pressure zone in and ocean area experience high pressure zone. Distribution of pressure in July. In July the situation is reverse as sun moves from equator Tropic of Cancer to Tropic of Capricorn. At that time sun overhead on Tropic of Capricorn, and in the month of July there is a summer season in southern hemisphere and winter season summer season in northern hemisphere and winter season is southern hemisphere. So, situation is reverse that time. In the ocean area experience high temperature because in some in month of July or summer in ocean area has had low temperature in comparison to land area, because land heat up early in comparison to ocean, and land experience low temperature zone. You can see the yellow color in month of July experience low pressure is and isobar of high pressure of 1026 located in Atlantic Ocean, sorry, Pacific Ocean, and also in Atlantic Ocean. So, earth rotation and gravitational force are two basic factors apart from temperature which determine the pressure of any area. Earth rotation produces the Coriolis effect, which is the tendency of air in motion to be turned toward the right or left. The direction of action and air of this turning effect can be stated thus: any object or fluid moving horizontally in the northern hemisphere tends to be deflected to the right of its path of motion, regardless the compass direction of the path. In the southern hemisphere, a similar deflection is towards the belt of the path of motion. Both wind and ocean currents patterns are greatly modified by the Coriolis effect. The Coriolis effect is absent at the equator, but increase as we move towards the pole. And we can see this is in the this figure show the turning of wind. This is due to the Coriolis effect. According to pressure belt, winds move from high pressure area to low pressure. This in actual this will be a straight in line, as already this figure turn in eastern direction and southeastern direction. Northeastern direction of high pressure in upper side and southeastern direction in lower side due to the Coriolis effect. This is not move straight due to the Coriolis effect. Today I discuss two factors of temperature and pressure, and they are very much related to each other, as temperature control pressure, and pressure is determined by temperature of any place. So, and all two factors are determined by several other factors like ocean currents, like height, altitude of the region, latitude, other coastal distribution of land and sea, cloud, transparency of atmosphere. All this combinedly affect the amount of insolation, and amount of insolation is the representation of total temperature. Total temperature is the reason for the how much area is how much of pressure will be in any region. So, that climatic element which influence climate from one place to another and from one season to another season are called control of climate. All the climatic elements and process are driven by energy received from the sun. So, sun energy is very important for us, because all the system of earth surface, ocean, biological things, land area, all are react or act according to energy, and this energy comes from sun. So, if we any obstacle arise due to a human or human induced problem like global warming, then our solar energy affect, and this solar energy is can change the climate. All the climatic factors of climate, temperature is primarily important, which determine pressure and various other processes like evaporation and precipitation, which I will discuss in tomorrow. And atmosphere pressure is very closely related to air temperature. Thank you.
Right, thank you, ma'am. And of course, a very interesting lecture. And so today we discussed temperature and pressure, and 2 more factors you will discuss tomorrow. So can you tell us why you have chosen only these 4 components and not any other?
Yeah, there are so many factors of climate, but I choose only 4 because they are the basic in nature, and they control all other smaller factors, and they also control the following these 4 factors, and according any climatic events occur or any prominent extreme weather event arise, mainly there are the 4 reasons are responsible for that. If 1 or 2 factors are very active, the any event may be possible.
Right. Yes. So they are the main and the basic components. So that is why ma'am chose to discuss them. And just very little time left. So maybe I can ask you 1 or 2 questions just to explain briefly what are oceanic currents, ma'am. You talked about in your presentation.
Oceanic current is the movement of ocean. It is like a wind.
Right.
Wind act in a air or surface, but this movement of water act in a water area, and this is also in 2 types in their nature. Warm and cold. When area experience warm, more temperature, in that region experience warm current, and like a tropical region have warm current, but at the same time polar region experience low of temperature. In that origin of that region of in that region there are currents in cold by nature, and they move each other to actualize the temperature and of Earth's surface.
So can we say that oceanic currents are usually natural processes?
It is a natural process.
Yes.
It is a natural process.
Natural process.
And only this origin by the change of due to the changes of temperature.
So can we say that these currents can also lead to calamities?
Calamities.
Not always.
Because I take 4 factors of that which act in atmosphere. Because oceanic current act in a land surface, the ocean volume. So I don't take with the main factor. It is a factor.
It is a factor, right? Absolutely. And like you said, these are natural processes. And another term you used is doldrum.
Yeah, doldrum is the low pressure region of area of equator, which is located 0 degree to 5 degree north and south, and this is a low pressure area and calm in nature. In that area, the winds comes from both sides, high pressure area to low pressure area, and here they mix, and the whole region is known as a doldrum region.
Right. So I think it is very important to know the meaning of these terms to understand the concepts better, of course. And also, ma'am, you talked about the Coriolis effect. Can you explain that a little bit?
Coriolis effect is the is also natural. It is due to the rotation of Earth. Due to the rotation of Earth, a force arises in mid. Due to this Coriolis force, anybody or any fluid or liquid moves their direction, and in northern hemisphere they turn right, and in southern hemisphere they turn left in their direction. So due to this reason, the pressure change of that area according to rotation according to rotation and gravitational force arise the Coriolis.
So is it a beneficial process for nature? Should this effect be there?
Yeah. Because due to this, there is no actualized process. Due to this force, not winds not move straight. and they turn left and right. So in this direction they turn, they affect that area.
Okay, okay, right. Thank you, ma'am. And of course, to end, I would like to just ask you a bit about the polar high pressure belt. Can you just tell us something about it?
Polar high plus, there is 7 pressure belts in total. 3 and types of 4 pressure belt, because one is common, 3 in both hemisphere, and one is common. Total 4 types, but number in 7.
Okay.
So polar high pressure is located in both the poles area, 90 degree north of latitude and 90 degree south of the latitude. This reason, because at this region area experience low temperature, and due to low temperature, pressure became high, because temperature and pressure, they have a opposite relationship.
Okay. Right. Thank you so much, ma'am, for being here today. And of course, we have learned about the 2 factors, temperature and pressure. And tomorrow we shall be dealing with another 2 that ma'am has chosen. So, friends, with this we thank ma'am and also take your leave. Thank you, ma'am, for being here today. And thank you, friends, for watching. Have a great day.